Okay, so we're on record. I wanted to start with, should be a review of the unit circle, maybe not. Discussion of the unit circle. So, in some way, you should have something like this in your notes. So maybe take a whole page. So for the stuff we're going to do today, you're going to be able to either use the unit circle or use special right triangles. I want you to have the information for both. Yeah. Okay, so we've already talked about the special quadrant angles. Zero and 360 are the same spot, then 90, 180, and 270. And then we have some other special angles. You should, yeah. You got to memorize this? No, you can't. So the stuff we're going to do today, after this, I'm going to say you can either do these by memorizing the unit circle, and some people like that, some people have already done that, and so or I'm going to say use the special right triangles and some of the ideas we've been using already. Okay, so in the first quadrant we have our 30, 45, and 60. And then in each of the other quadrants we have angles that we can use 30, 45, and 60 as reference angles for. Okay, so I'm gonna add also the radian measures. There's three things we need to know about each of these angles: the degree measure, the radian measure, and the coordinates. So 360 degrees is 2 pi radians. 180 degrees is pi radians. 90 is pi over 2, and 270 is 3 pi over 2. pi. Did it?
Also, I don't stand on head. If that was on video, maybe the chairs are going to. Are you recording this? Are you recording?
Okay, so we can find the radian measures of all the other angles. Now that we're all awake. And you can do that by multiplying each degree measure by pi over 180. So let's not do that for everyone. Let's do it for the first few. They say the first thing to do whenever you get hurt or something like that is like get back up on the horse. 30 degrees is 1/6 of 180, so it is pi over 6 radians. .45 is 1/4 of 180. It's pi over 4 radians. And 60 is 1/3 of 180. It's pi over 3 radians.
So do we have to memorize these measurements? Or is this different for each way?
You can multiply degree measure by pi over 180 to get the radian measure.
Okay.
You're going to go watch the lesson video from last class, and you're going to learn all about that.
It was 195. Just actually last class.
Oh, so you were here for the radian thing?
Yeah.
Oh, well then fine. So 150 is related to the 30-degree angle. 150 is 5 times 30. It's 5 pi over 6. Uh, 135 is related to 45. It's 3 times 45. It's 3 pi over 4. And 120 is related to 60. It's 2 pi's over 3. So I'm going to go fill in the rest. Just let me know if you need one of them.
Okay, so 300 would be related to 30, right?
300 is related to 60.
Oh.
It has a 60-degree reference. 60 degrees away from the x-axis.
But you don't have to. You can just do it how we learned last time. It's just longer.
Depends on how you might use. I don't use limits. Okay, so one more thing about this. I'm not going to do the whole thing. I'm going to show you how to get them, and then you can grab them out of the book. Because this whole thing is in the textbook. So each of these quadrant angles and then each of the other angles has coordinates associated with. We've talked about the quadrant angles. This is 1, 0. X is 1, Y is 0, R is 1. 90 is 0, 1. 180 is negative 1, 0. And 270 is 0, negative 1. Okay, so in the unit circle, when we're talking about circular functions, if I know the coordinates for the angle I'm given or the radian measure I'm given, then I know cosine and sine already. The x coordinate tells me cosine, and the y coordinate tells me sine. So the sine of 360 is 0. The cosine of 360 is 1. If you know cosine is x over r, cosine is x. Y, or sine is y over r, sine is our y coordinate. These other angles, we get the coordinates by using the special right triangles. So let's do 30. So for my special right triangle, I have a side of 1, side of root 3, and r is 2. The x value of my coordinate is going to be the cosine of 30, so root 3 over 2. The y coordinate is going to be the sine of 30, which is 1/2. So the coordinates for pi over 6 or 30 degrees are root 3 over 2, 1/2.
Where did you get the cosine and sine?
Yeah, how did you get that? Can you explain this one more time?
How do I get the cosine?
Yeah, cosine.
Well, I know cosine. Well, you just got the cosine from 1, right? Or,
Cosine is root 3 over 2. X over r.
so are you just using the special right triangle? Okay.
So the special right triangles will tell us these coordinates.
Well, how do you know that's x?
I told you, cosine is always x, sine is y.
Oh, okay.
That's just the way it is.
Okay.
Yeah.
So what if you
It is fact.
what if you use like a extended triangle? You still use cosine and sine.
Cosine is x, sine is y.
Okay, and then you just use the different angles and different applications.
Yeah. So, if you memorize the unit circle, if we went and put all the coordinates on the unit circle and you memorize all of them, then finding sine, cosine, and tangent, and all the rest, you could just pull them off the unit circle. But if you're like me and you don't like to memorize them, we can use the special right triangles. Questions? Does anybody have the unit circle memorized? Cool.
So is this just a second option of what we were doing like 2 classes ago, kind of in a way? Or like a class ago?
Like finding trig functions and all
Yeah.
that? Yeah.
Okay.
This is too much for my brain to process at once. I'd rather just do some work and find the answer. Go ahead. So we lost.
Aren't we all?
Yes. Okay. So we haven't dealt with finding the trig values when we're given a radian measure, and it's almost the same. It's pretty much the same. So now, if you knew the coordinates for 3 pi over 2, you could take the y value from 3 pi over 2 and tell me that the sine of 3 pi over 2 is what? Negative 1? Okay, so the advantage of knowing the unit circle is that you could just pick that value off the unit circle.
So why is it?
No, sine, the answer is negative 1. So it says Jack. So the other way to do that is kind of the way we've been doing things. 3 pi over 2 is the same as a 270-degree angle.
So 3 pi over 2, that's 270 obviously, so you don't put the 0 and negative 1. The 0 is for the x, right? You don't include that in the answer, just negative 1.
Right. Well, I guess this is the same way anyways because it's a quadrant angle. So 270 is a quadrant angle. My x is 0, my y is negative 1, and r for these things is 1. When we're in a quadrant angle, we're dealing with a unit circle, 1 unit. So radius is 1. For a quadrant angle, 0, 90, 180, 270, 260. So sine is y over r, and I'm going to use 3 pi over 2 because that's what we're being asked. Y is negative 1, r is 1. So that's correct. That's sine. So 2 ways to do this. Pick the y coordinate from the unit circle at that radian measure, or do the same thing we've been doing. Sine is y over r, plug in the values. Let's do another one. This is not a quadrant angle. Cosine of 7 pi over 4. Root 2 over 2. Let's see. So it's the x coordinate at 7 pi over 4. So 7 pi over 4 is the same as 315.
Wait, how did you get root 2 over 2?
It's the x coordinate at 7 pi over 4. So if you know the unit circle, you can just pick the answer right off the unit circle. But if you don't, then we're going to keep what I'm doing.
Yeah.
Okay. And you don't necessarily need to draw the picture, I'm just going to do it. 315 has a reference angle of 45. So that makes this side negative 1 because I'm in the 4th quadrant. This side's 1. And that's root 2.
But how do you know it's
You can convert 7 pi over 4 to degrees by multiplying by 180 over 5. Cosine's x over r. And so then when I rationalize 1 over root 2, I get root 2 over 2. So I did some talking and I did some waiting and I didn't do very much writing and I still got the same answer. And I probably could do this part in my head. So you choose the way that works best for you. If you want to memorize the whole unit circle, so you can just pull the answers off, that's fine. If you want to use our knowledge of reference angles and special right triangles to just find the answer you need, that's fine with me as well. So try those two. Okay, so again, it doesn't matter which method you choose. But if you're going to use the unit circle method, do me a favor, on your quiz or test, write unit circle method. Okay. Otherwise, I might think you just copied somebody. I know nobody's going to do that here, but you know. So if you went to 2 pi over 3 on the unit circle and you picked off the x-coordinate, the x-coordinate's negative 1/2, you'd know the cosine of 2 pi over 3 is negative 1/2. Or you can do it this way. Cosine of 2 pi over 3, that's a 120-degree angle, which is in quadrant 2. Its reference angle is 60. So when I'm staying here and everybody turns and faces the door, make sure I label my sides right. The x value is negative in quadrant 2. Cosine of 60 here is negative 1 over 2. So the cosine of 2 pi over 3 is negative 1. I could do the same thing for tangent of negative 5 pi over 3. Going negative 5 pi over 3 is the same as going positive 1 pi over 3. You end up in the same spot. Negative 300 is in the same spot as positive 60. So we're in the first quadrant. To get the tangent using the unit circle method, you have to take the y and divide it by the x. So that might be the only spot where the unit circle method gets a little messy, because you're dividing a fraction by a fraction. Or you could set up your 30, 60, 90 right triangle, and tangent is y over x, which is root 3 over 1. That's just root 3. What would this look like? So the unit circle method, you would look like this. Where did yes, yes. Alright. Yeah, the twos cancel. Uh-huh.
Can you repeat one more time why your triangle in the first quadrant?
So negative 5 pi over 3 is the same as negative 300. So negative goes this way. And 300 degrees lands us in the first quadrant.
Okay.
I have one more type of question. No. Those are fractions. Okay, so we're going to do the reverse. instead of finding a function value, I'm going to give you a function value. I'm going to tell you in which quadrant or on which interval. And then I want to find the angle.
This math is always so good.
So this,
Yeah, now I have to memorize something. They don't let it start. They don't have to.
you don't have to memorize the answer. You don't have to. I never told you you had to.
You said we can't use that with us. Now we don't.
For those of you listening at home, you don't have to memorize the unit circle. You have to know some stuff about it. So I need to know that pi over 2 is right here and pi is here. So what I want here is I want to look at this quadrant between pi over 2 and pi, and I want to know if the cosine of my angle is negative 1/2, which angle did I find the cosine of? So cosine is x over r. Oh, that's actually. In the book, they use S. I think because they want you to give the answer in radian measure. So if I have my triangle here, the one special right triangle that has a hypotenuse of 2 is the 30, 60, 90. That makes this side root 3. So that means that's a 60-degree reference angle. So we're kind of reverse engineering what we just did. So if this reference angle is 60, the original angle is how big? 120. Which is 2 pi over 3.
How is it 120?
Okay, so I used cosine. Cosine, that's my x and r. So I'm sort of going backwards. Now I'm using the function value to build my special right triangle. So my x is negative 1, my r is 2. We'll do another one. And then these are 2 of the sides of a 30, 60, 90, making this one root 3.
I just understand, like, if it's in the second quadrant, why would you just use 30? Because that will just do the rest until...
Why wouldn't I use 30?
Yeah.
Why would I use 30?
Because if you're just in the second quadrant, so it's that quadrant is 90 and 60. Over, so 30 is left. I just don't understand how you got 120.
Oh, there's 30 here,
Uh-huh.
plus there's 90 here.
But why do you have that 90?
Because my angle always starts here.
Oh, okay, got it.
Cool.
Got it.
Alright. So let's do another one. Spoiler alert. So I'm between pi and 3 pi over 2. That means my angle is in the 3rd quadrant. It starts there. Cool. So I have my reference triangle. Sine is y over r, so that means that this part of my reference triangle is negative 1, and this is 2. Here's my reference angle. If it's across from the 1 side, this is a 30-degree angle. So I know that because the special right triangle with a hypotenuse of 2 is a 30, 60, 90. The side across from the 1 is 30 degrees. So now I have my whole 180 plus 30, which is Hannah. 180 plus 30 is 210.
Mr. Baker,
Yes,
can you retreat the negative since it's on the left side?
that's right. It's negative. Seven, 5, or 6?
Then 756 your answer.
Yeah. I'm not too concerned which one you tell me. You can tell me in degrees or in radians.
And you do it with a 30-degree angle. How?
Because when I put the -1 and 2 on here,
Okay, so they're not.
the special right triangle with a 2 as the hypotenuse is the 30, 60, 90 right triangle.
Yeah, but how did you know where to put the -1 and the 2 on the triangle?
Sine is y over r.
Oh, okay.
Let's skip that one. So these 7 through 21 are like the first type of problem. 61 through 67 are like the second type of problem. Both of which we got a quiz on Friday and then on the test next Thursday.
Do we have a talk today?
There is a Todd today, and it looks like the ones from 7 through 21. So there'll be 2 questions like these ones. Okay, so I'm saving you a little bit of pain. No Todd on this piece, but this is a piece that you need to know for the quiz.
Like, 7 something we just did with the circle area?